Hello, hello, sir, you are not audible, sir.
I haven't started it. I'm starting. Yeah. So, good evening, everyone. Hope my voice is audible now and my screen is visible. Um,
Yes, sir, audible.
yeah, thank you so much. So, a small introduction about me. So, welcome to the week six section of this problem solving session of NPTEL for the course Air Pollution and Control. So, I am Saravanan, PhD scholar and Prime Minister Research Fellow of NIT Tiruchirappalli in the Department of Civil Engineering. So, as a part of PMRF TA-ship, I am taking this problem solving session for the NPTEL course Air Pollution and Control. I have already taken two more courses like solid waste management and plastic waste management last two semesters, and you can also go through that videos in my YouTube channel as well as in the SOIM portal. And so we are in the sixth week of this course. So in this air pollution and control course, we have seen about this. What is air pollution? What are the different air pollutants and types of air pollutant and its sources? What are its impact on the human health, environment, and different materials, and how it's affecting the global and national economy. And then we have discussed about what are the meteorological parameters that mean like wind speed, pressure, temperature, how it affects the dispersion of different pollutants. And then we also discussed about plume models, how to find the pollutant concentration in different places when it is emitted from a chimney. And we have also discussed in the last week about emission inventories. Sorry for the last week, because of my internet connectivity, I have taken the composition session yesterday. Hope you have attended that also. I have uploaded the video again. And this is the sixth week we are going to see about how to find the emission inventories. So what is emission inventories? So that are the data that was collected for the air pollution standard makings, and how to collect this type of data. That are all called inventories. So the various methods are available to find the emission inventories. And this week we are going to see about emission. Um, yeah, I'll move on to the presentation. Okay, so the first lecture will go with this emission inventory case study that is pending of last week, and then we are going to see about the emission allocation, or what we call it as there is a one second. Okay. So first we will finish this case study on emission inventory, and then we will move on with this apportionment, that is called allocation of different emissions from different sources. So if you have 100 microgram per meter cube of particulate matter, or carbon dioxide in your city, then you have to tell what is the source for this pollution emission. If I found carbon dioxide is more or sulfur dioxide is more, what is the source for the solution, source for this emission? That I can say, like this industry or that industry, how to calculate which industry. So that is called emission apportionment. So it is called allocation of different. If it is 100 microgram per meter cube, then 10 is coming from this industry, 20 is coming from this industry. How to allocate? How to find this source? So that and all we are going to see in the upcoming slide. So okay. So first we will finish with this emission inventory case studies. Hope you are giving this assignments for every week, and yesterday it was the deadline for. I mean, sorry, tomorrow is the deadline for week 6 assignments. And if you want certificate, please give the assignments. And the exam application deadline is over already. So please study for the exam also. So it will be maximum based on the assignment problems. Okay. Yeah. So they have done case study in Delhi to calculate the what are the major hotspot for the different pollutant that was identified by this emission inventory case study on Delhi conducted by Pollution Control Board and with NEERI in collaboration with IOCL and R&D centers. So their objective is to find a baseline air pollutant level. So how to I mean what are the different air pollutant at the baseline? So without emission, what is the baseline air pollutant level, and after emission, what is the air pollutant range? That and all we can easily calculate with this emission inventory studies. So for the air toxic levels, and then they also identified the hotspots near the outside locations, and also they developed a emission inventory for various air pollutants for project analysis. And also they conducted source apportionment studies or particulate matter. So because particulate matter is a major pollutant in Delhi, they have considered, and they delineate the urban air quality management plan based on this inventory results. So first, how they did, for the emission study, they have two scales. One is 2 kilometer cross 2 kilometer, that is the smallest area. They initially have a delineation. Then sorry for that. Then the emission inventory was extrapolated to the total emission of the city. So first they have worked with the small scale level, then they extrapolated to the whole city. That was the initial plan. Then later the emission inventories of they have considered three sources. One is industrial, then area, then line source, that is the vehicular source. So these three are the emission inventories they have chosen, and the primary and secondary data were collected. So primary data was collected from questionnaires, and the secondary data was collected from different government agencies and private agencies. Okay, so the location you can see they chosen 10 locations. There are the study zones we can say. So in and around Delhi they have considered, and they considered five major air pollutants that are particulate matter, sulfur dioxide, PM10 I am talking about, and then sulfur dioxide, NOx, carbon monoxide, and hydrocarbon levels. And then, as I mentioned, they have three sources. One is area, point, and line source. So line source is from vehicular emissions. So area, how the data collection was done for land use, land area maps they have used, and population, commercial activities, and fuel use data. Everything they have they collected as a data, and the emission factor was calculated from the US EPA studies. And then emission loads was from different activities they have calculated. The point source data was collected from industrial emissions and different agencies, and the line source data was collected from the RTO because it's from the vehicular emissions, and also from the oil depot and the gridwise road length. These are all the data required for line source emission inventories. So, and the emission factor was taken from the CPCB and the ARI Pune. You can see what are the types of sources they have considered for area sources, point sources, and line sources. And the data was collected from, as I mentioned, the first is data collection. So activity data was collected from the government and non-governmental agencies, and the primary data was collected for this 10 study areas. You can see here what are the sources and what are the location different. So I mean, in area itself, what are the different sources they have calculated, and point sources and line sources, what are the locomotives. In point sources they are talking about open burning, and area sources they have taken different industrial and commercial sectors, and in and around the same 10 locations, study area locations. Okay, this is the number of sources. And then data analysis, if you see, for the data analysis, these are the sources like hotels, crematorium, medical waste incineration plant, generator sets, open burning, diesel locomotives. You can see lots of photos from the study area. And the area emission factors were calculated from the CPCB recommended values, and EPA studies, they have taken the correction factors. Then the load estimation was calculated. They taken five data. First is the population, second is the slum population, because for the 2 kilometer cross 2 kilometer, they have to, as a smaller area study, they have to take from, one second, people are coming. So they have to estimate for different areas. So for that, they have first taken population in 2 kilometer study area, and then the slum population of the same 2 kilometer class 2 minute study area. Then the fuel consumption of the people. Then the comparison of fuel consumption should be done for seasonal variations like summer and winter seasons. Then they identified the land use based on the ECHR map. Yeah, nowadays we are having Google Maps for the study area allocation, but earlier they have used the ECHR map. ECHR map is the map which shows all the buildings and the roads and tree cover, everything in and around Delhi. So that they have used. Then for areas, again, five major pollutants, as I mentioned, these are the pollutants they have considered. And uh, so emission load was taken from the open burning, and PM was, load was due to construction activities were considered, and percentage emission contribution from the different sources. That's what the aim. How much percentage each source is emitting. Finally, preparation of overall average fuel consumption and emission scenarios. That was comparison of different scenarios. If this happens, what will be the emission? If this happens, what will be the emission? If the policy is good, what will be the reduction in the emission? That's what we can identify with emission inventory models. So yesterday also I have discussed lots of model for industries, commercial areas, residential areas, then agricultural sectors. Um, and vehicular emissions. These are all how to calculate the emission inventories with the different scenarios comparison. We have discussed yesterday with the different models, and also OPI models we have discussed for emission inventory for industries in India. Yeah. So here you can see total emission from the area sources. They have taken the same five pollutant, and location you can see, and the maximum and the minimum values are shown in this graph. And the location also we can identify easily. And the point source from the industries they have taken from each chimneys are considered as a point source, and also from industry boilers and furnace. Total emission load in the study total emission load in the study zones from different industries were computed. So the data was collected from the National Council of Applied Economic Research. So they have the industrial data. Then the number of industries, like 17,112 populating industries in Delhi. That's what the data. And out of that, 22266 units are air polluting in nature. And also they have considered large scale industries. Out of five plants, three are located in IP estate and two are from Pragati, that is the area in Delhi. You can see from the 10 study locations. And medium scale industries are also taken into consideration. So you can see the results and compare. I will show the results, that you will understand how the inventories were working out. And the data was also categorized into nature of product and byproduct, because different industries will vary. So what are the industries which producing food products, pharmaceutical products, plastic industries, textile, rubber, meteorological, chemical. So the inventories are also categorized based on the byproduct and product nature of the industries. So if you see here, yeah, the emission level in kg per day will be higher for engineering and metallurgical industries, and pharma and food. If you see, you can see this NOx is the gray color. So NOx is more in all the industries, and if you see pharma and food, CO level is also higher. Yeah. So also they have considered based on the locations. So everywhere you can see NOx is higher and the total emission is higher in SSI GTK location. Yeah. So line source, if you take vehicular emission as a source, so major source of category for air pollution in Delhi is vehicular emission, and that so vehicular population is growing from 64 to 72% in one decade itself. So you can assume how much emission will happen from each vehicles. So the methodology they have taken is they have first collected the primary data from the government sector, or also other field studies data they have collected as a primary data. So total daily traffic volume, peak hour traffic composition, composition on working and non-working days also we need to compare, and estimation of traffic composition on different types of roads, and VKT, that is the vehicle kilometer traveled. So that is VKT. Total VKT is also considered in the study. And estimation of vehicular emission loads, they have monitored in the field, and estimation of percentage emission contribution SOT emission, resuspension dust load, because from each vehicle there will be exhaust emission, there will be a non-exhaust emission that is due to resuspension of particulate matter and heavy metals from the road, and preparation of overall traffic emission were also considered. So here, that's what the field study I'm talking about. So traffic survey was conducted for vehicle count. I will one day I will tell you how to do this vehicle count. That is a transportation sector. So I will teach you how to calculate the vehicle count by sitting on the pavers. And vehicle moving on the arterial ring roads, and so these are the different types of roads also they are taken into consideration. So they are taken for 12 hours duration between 8 a.m. to 8 p.m. and the non-working days also they have compared. So you can see how much two-wheelers, four-wheelers, and the trucks, buses, and all in arterial, main roads, and feeder roads. These are the three types of roads. How many? Which is more in the main roads, and yeah, if you compare main roads, they have a large vehicular count. That's a traffic count. So VKT also considered for each study zone. VKT is the vehicle kilometer traveled. So if you see for different 10 different zones, arterial roads have most vehicle kilometers run. And the assumption for the emission inventory is fleet age consumption is 10 years, and 2 years and 4 years two-wheelers, that is two-seater and four-seater two-wheelers ratio of 72 to 28 has been considered. That's the assumption I'm talking. And then four-wheelers are 92% petrols and 5% diesel and 3% CNG. This is assumption. And buses, what are the fuel consumption, that also they have taken into account. So emission factor was developed by ARI, and this sulfate emission is estimated based on the fuel consumption. So if you see here, what are the five different considered pollutants and their emission levels. So CO emission was found highest for NOx. If you see here, followed by CO is higher compared followed by NOx. Lowest emission was observed for SO2, SOT emission. These are all due to vehicular emissions, or the line source. Okay, so vehicle category wise emission. If you see, trucks are having more emission, and four wheelers are having more emission as per for CO emissions, and hydrocarbon. If you see, two wheelers are having more emissions, and NOx is more from trucks. So trucks are the one which is emitting a lots of pollution. So PM, if you see, trucks, carbon monoxide, four wheelers, hydrocarbon from two wheelers, and NOx from heavy duty vehicle, HDL. So if you observe a pollution which is higher, then you can stop that type of vehicles in that season. So mostly the vehicular emission contributes to the major part of Delhi's air pollution. That's why now the government is also working on with odd and even number of vehicle travel in odd days and even days, and then they are also working with car sharing. If you are going to the same company from the same apartment, you have to travel with the same vehicle, and promoting public transport will also reduce the pollution level. So these are all different initiatives the government is taking to reduce the pollution from vehicle emissions. And resuspension, if you see the results, resuspension due to for PM10 is higher in ISBT location and SSD locations. And these are all the summary for each study zone and different types of pollutant. So city level emission inventory was also conducted. So the 10 study areas they have mapped. The main purpose is, as I mentioned, first study is 2 km cross 2 km. Then it was extrapolated to the city level emissions. So the inventory was also prepared in terms of same five pollutant for the whole city. For the whole city, we need the population data, fuel consumption data. Then the total daily area source emission load of different pollutants in Delhi was estimated. So these are all the factors. Or the source emission load. So the emission from the domestic slums are highest source of emissions. So you can see here, domestic slums have highest emission from area source. So if you see, PM10 is more from hotels and restaurants, and sulfur dioxide is more from the bakeries. So this is the result for the area source emission. Again, if you see, NOx is higher from reduced generators, and carbon monoxide is higher in the domestic slums, and HC is also higher in domestic slums as well as residents. So most of the residents and domestic slums are contributing to larger emissions. This may also be due to the micro and small industries that is located in the residential and the commercial areas within the residential areas. So this is the grid-wise emission inventory for the area source. So if you see, the red marks are having the higher level of pollution. So that location you can see K5 and 6. I mean H7. These are all the locations that are having more pollution levels. So you can see here. So the NEERI team visited all the 36 industrial locations, and these are all industrial emissions. After the area source, they have come with the industrial emission level. So they have visited all the 36 industrial estates, and they identified thermal power plant is the major share for the industrial emission for the carbon, sulfur dioxide and NOx levels. So, because they are using lots of coal as a source for power production, and ESP is also due to use of cleaning and beneficial coal. So ESP is the electrostatic precipitator, that is a equipment used to control the air pollution. So we are going to see different air pollution controls technologies in the upcoming weeks. So the emission, if you see, the blue color shows the maximum level, right? The blue color is hydrocarbon, and sorry, the PM10, and carbon monoxide is also higher here, if you see. So thermal power plant in different areas are emitting lots of carbon monoxide and PM10. So in the medium scale industries, if you see, not the thermal power plant, I'm talking about the medium industries. If you see, the NOx is very high comparatively in the 36 industrial estates. If you talk about small, medium, and large industrial scale variations, everywhere the large industries are emitting a lot comparatively. But if you see the carbon monoxide emission, that is more from small scale industry. That is a notable result you can see from here. All other pollutants are more in large scale industries, but only the carbon monoxide is higher in small scale industries because of incomplete combustion, not non-usage of full oxidant. So this is again a grid map for the emissions from the industrial source. Here you can see ISBT and Ashram Chowka, the location which is having lots of pollutant emission. Yeah. So that was mapped with the each city map of Delhi, and the methodology they have adapted is total length of, as I mentioned, three lanes they have considered. One is arterial roads, main road, and then feeder roads are all taken into consideration. Total daily vehicular emission load in metric tons was given here. So that is the base data they have used for Delhi. And the resuspension rate for PM10 and PM2.5 is also estimated as 7.3 and 5.7 metric ton. This is a so this is the grid-wise vehicular emission. So first is area, then we have talked about industries. Now we are talking about the vehicular emission. Here again, if you see M8 grid. So if you talk about M8 grid, this is the major emitting area. That is the location is given, I guess, somewhere. Yeah, M8 is India Gate, Vigyan Bhavan, and Udyog Bhavan. So this is the area in the M8 grid, which is emitting a lot of vehicular emissions. So these are the identified hotspot. The red marks are identified hotspot. You can see from the same Eicher map. And the total emission was also given for the total 10 locations. Here you can see everywhere NOx is higher, followed by carbon monoxide. And if you compare area, point source, and the line source, because area source we have calculated, point source we have calculated from industries, line source we have calculated from the vehicles, and if you compare this three, you can see carbon monoxide is higher in line source, that is from the vehicular emission. From the point source, NOx is higher, that is from the industries, and area source are emitting carbon monoxide again more. So residential areas are emitting carbon monoxide, and the vehicles are also emitting carbon monoxide and NOx. Industries are emitting more of NOx. Okay. Yeah, this is the summary of the result. And total emission at city level was also given here, like industrial, vehicular, and road dust emission. So if you compare the source-wise emission, source-wise in the sense road dust area, industries, and vehicles, this type of sources, if we compare, PM is higher from the road, and carbon monoxide is higher from vehicles. NOx is higher from industries, hydrocarbon is higher in the vehicles, and also SO2 is mostly from the industries. Minimum, that is around 98.8% of sulfur dioxide is from industries only. So if you compare this, you can get a broad idea where the emissions are coming from. So you should not only think industries are emitting the pollutant. Even vehicles are also emitting pollutant. Even residents are also emitting a lot. Even if you see particulate matter are higher in road dusts. So this is due to resuspension of particulate matter from the road. So that is another major contributor. So as a conclusion, if you see that this is the case study results from Delhi using the emission inventories. So they have calculated for the point, line, and area sources from domestics. So the primary and secondary data were collected and the hotspots were identified. So the specific pollutant which contributes from different sources were also calculated from this results. You got the broad idea about this emission inventories, I guess. So you can also put it in different models and you can find as we discussed yesterday. Okay, now we will move on to the source of apportionment. Apportionment is the allocation of percentage to each sources. So as I mentioned, if carbon dioxide in Trichy, if I say is around 10 100 milligram or a microgram per meter cube, then if I say which industry or which landfill or which domestic area is contributing to this, so I have to give different allocation. For that, I have to use two approaches. One is bottom down and then top down and bottom up approaches. That and all we can use to find which source is emitting this much pollutant. We can give like 20% is from industries, 10% is from landfills, and 60% is from vehicles. So you can also give, and each industry also you can give this apportionment. So that's the basics. So a source apportionment is the practice of deriving information about pollutant sources. Which source? That's what this. If I see this graph, you can get a broad idea. So industries, domestic cooking, waste burning contributes a lot. Different parts of pollutant. You can see 45% of pollution is from dust and constructions. So this is a major contributor again. Other than waste burning and industries, so the industry is contributing only 8%. Waste burning itself 17%. So if you see about dust, it is from the construction and demolition industries. So that this type of allocation is called waste apportionment. So how to quantify this pollutions by regional sources, long range transport and transboundary transport and natural sources. So uh, these are all sources which contribute to the pollution, and identification of sources are of particular interest, like any pollutant you can say, and you can also detect with any type of sources. So that's how you will get into this emission apportionment. So there are two approaches, as I mentioned. One is for bottom up and then top down. So bottom up is from each industries how much it is emitting. Which will be connected to the sources. Top down is we will go and check the pollutant level. Then we will come up to the which industry. So I will explain again clearly. So first I will know what are the different industries. So I will add up from each industries, that will give you total emission. So that is bottom up each industry, then how much it is giving. So top down is I know after 1 kilometer what is the pollution level by Gaussian flow model or Lagrangian model, anything I can calculate what is the pollution level there. So I can back calculate from which industry it is coming from. So that is top down approach. So I know the emission level, I am calculating what is the source. I know the source, I am calculating what is the pollution level. So this is called bottom up and top down approaches for source apportionment. So I am talking about bottom up now. That is called source based method. So I am beginning with identification of emission activity and pollution sources. So first I am calculating which industry is emitting a lot. Then I am calculating the estimated ambient concentration. So that is called the bottom up approach. So first step is identification of potential sources and their physical and chemical processes, how it is forming into secondary pollutant and how it is disposing. Then baseline map if I know, and then apportionment of pollution by different sources I can give. So if I know domestic it this much and then industries this much, like open burning this much, then I can calculate with the total pollution source, though I can have the percentage levels. So how to identify the potential sources? So it's by physical and quantitative analysis required for the preparation of emission inventories. And if you see how to find the physical and chemical processes involved in the emitter sources, you can go with the local topography and metallurgical features that will help in conversion or transformation of different pollutants. Like if SO2 is emitted, if it is having a lots of moisture content in the ambient air, then it will be converted to the H2SO4. If like nitrates is emitted, then it will be converted to nitric acid. So that meteorological fact features that will contribute to the physical and chemical processing. Like physical process in the sense it will abrade with some other PM and PM10 and 12.5 will abrade with some other obstacles, and it will also reduce in size or increase in size that will contribute to pollution transformations. So required for the dispersion. This is also required for the dispersion modeling. Then how to find the secondary pollutant formation by using chemical transportation models. Then we need to know the baseline mapping by Gaussian plume model and Lagrangian model. And then Gaussian plume model that we know that assumes the turbulent dispersion. So it will form the normal distribution pattern in both Y and Z axis. And you can also calculate the level of pollutant at the base level. Then Lagrangian model using a moving frame references to describe the trajectory of single and multiple particles. So that is another method to model to calculate the pollution level. So we know the Gaussian plume model equation. So based on the sigma and sigma z and the emission values, you can calculate the concentration at any particular location. Same Lagrangian model uses this equation with the average concentration, that is to find the average concentration, that is C R comma T at any time you can calculate based on the principle you can see here, moving frame of reference. Yeah. So this is the equation with the Lagrangian model. So what is the advantage with the bottom-up approach? Because it's locating pollution source through the development of emission inventories. So you know the solution, you know the location of each pollution sources and identify potential source of emission primary emissions. Initially, it's identifying and it's describing relevant physical characteristics that affect the ambient levels and understanding the chemical processes also. Also, it documents the secondary aerosol formation, not only the primary, and also it is having the chemical and the physical transformation mechanism, and it's addressing and documenting the secondary aerosol formation, and it identifies the sources that would most effective in controlling and affecting the ambient compliance level. Also, it's providing the spatial coverage of how the sources impacting the air quality and exposure. But the disadvantage of this model is it requires the laboratory equipments to assess how much pollution level, and heavily depend on the depth of activity levels and fuel consumption data. And experienced staffs are required to manage the maps and analyze skilled staffs as I mentioned. So now we are converting to the top-down approach. Top-down approach is we are going somewhere to measure what is the pollutant level, and we are going back from the emission to the emission point. So that is called top down. So bottom up is we know the industry, we know how much is coming, then we know how much is getting deposited at this point. Now we know what how much is deposited at this point. Based on that, what is the source it's getting from? That is top down. So I know the source characteristics, ambient concentration. I am finding what is the source. So for that we need a measurement techniques. Each pollutant, I am measuring CO2, I am measuring SO2 at this point, and I am going to check what is the source for that. So top-down nurture begins with the sampling of air and matching the common and physical characteristics between the source and the air pollution sample. If the carbon dioxide is more, then I can say some industries are emitting. So in NOx level is more, industries are more. Carbon monoxide is higher, then some domestic emission is there. So that is called matching of chemical and physical characteristics and finding the source. So here it starts with the identification of hotspot with the critical pollutant. I'll first find what is the pollutant, then identify the chemical composition of the pollutant, and then describing the source impact estimation and differentiate of the primary and secondary pollutant. Finally, I will approximate apportionment of the pollution by different sources I can find. So first step is identification of the hotspot. You can see here, and then sample collection and measurement and chemical analysis to match. Then the receptor modeling that will analyze and give you what is the type, what are the types of pollutant like primary and secondary. For that, another one name I have forgot to mention here. Yeah. Here, if you see, bottom up is source based method, and top down is another name is called receptor based methods. So, source based is we are finding with the source. Receptor based is we know who is getting affected or which place is getting affected. That is the receptor, or the person or the place who is getting the pollution. From there, I am going back to the source. So that's called receptor based. Source based is I know the source, I am going with how much pollution it will happen. Okay, so top down is another name is called receptor based model. Yeah. So here, if you see that's called receptor modeling. What are the models used in the receptor-based methods? Primary principle is mass conversion, because I am getting 100 microgram per meter cube at this point. then how much it will be at the source? 1000 microgram per meter cube. Then what? Where the 900 microgram per meter cube gone? So I have to check. That's called the mass balance. 100 is coming here. So at a different 10 locations, what is the total that will be at the source? So that is called the mass conversion and also energy conversion. These are the basic principles of receptor based model. So chemical mass balance is the CMD model method that uses this equation to find, that is called CMD model, chemical mass balance model, that is used in the receptor based modeling methods. So where to apply the CMD? For the apportionment of primary pollutant extensively used for the PM10 concentration and organic carbon contribution in the ambient PM 2.5. And then also it was applied to find organic carbon in Los Angeles and the PM 2.5 samples in different literature. If you find, they are used this um, chemical mass balance methods. And then multivariate method is there. Positive matrix factorization model is there. That is PMF model. These are all models used to find the receptor, used to apportionment the source. This is the equation for the positive matrix for factorization. And in the next lecture, we are going to see about the source appropriation using receptor model. That problems and all we are going to solve. Yeah. So now what is the advantage with this top-down method? It determines if selected monitoring sites are hotspot alone, it will determine not all the locations, and it identifies the critical pollution. It will not give a general way, it will give exact pollutant concentration and what is the type of pollutant, and may differentiate chemical composition of the PM and describe source impact estimates and identify the source, avoids uncertainties because we are going with the total actual mass balance, so there is no uncertainties. But the disadvantage is it's apply appropriate source profile which matches emission sources. So we need to know, we need to have proper matching source for the, if there is no source around, then it will be difficult to map with that, and it is not able to differentiate sources because if I am getting PM at my location, I don't know PM is coming from the open burning or PM is coming from the vehicular emission. I can say it is coming this area and it will be this much at this area. That may be the source. So there will be a maybe, that's called no differentiation between the source and not being able to fully account for possible non-linearity due to chemistry. And it poses a significant technical challenges and that agrees with the ambient measurement and allows for usual because there may be some baseline concentration that also we need to know. And not all the 100 microgram per meter cube is from the source, so there may be already existing level will be there, so the baseline is required, and then the 100 will be subtracted from that, that will be your actual value. So there will be some that are technical challenges, and top down approach allows for a useful information to be gained from relatively few ambient measurements. Okay, so how to integrate this bottom up and the top down method? So that's to get the advantage from both the methods, we are integrating it bottom up and top down. So by top down can identify the relative contribution of different sources categories, so that we can use the top down method. And then the interaction of top down and bottom up methods forms the interactive process of learning through which the source of air pollution can be precisely quantified, because it will neglect the disadvantages of both the models. So that's the conclusion. So the source apportionment provides the information on emission sources, which source is emitting, which pollutant, how much. So that and all we can get from source apportionment results. And then top-down approach is combined with the bottom-up approach is useful to get a reliable data. And why we are doing this? It will help the policymakers with realistic techniques for identifying and measuring the several source of air pollutions. Okay. Yeah. So we are now going with the same receptor model, that is the top-down approach, because it is more common method how to do this receptor model source apportionment. That is we are going to do check in detail. So source apportionment is, again I am selling the explanation. It is a practice of deriving information from the pollution sources and the amount that they contribute to ambient air pollution level. How much each contributes to the total pollution. That pie chart is called source apportionment. So the receptor model is the top-down approach. It's a mathematical or statistical tool used to identify the source of pollutant and quantifying their absolute. Okay. So this also uses the chemical and physical properties of gases and particles. So it will give you what type of particulate matter also, and both detect and quantifies the presence of source contributions. So this is the whole map behind the receptor model. As I mentioned, first we are identifying the sampling site and we are measuring, we are analyzing, and when we are going with the receptor data analysis, finally we are mentioning which source is telling by mapping with various sources. Yeah. So as I mentioned, mass balance and chemical mass balance (CMD). These are the two models used for receptor model identification. So the data set with the rather large amount of data consisting of the chemical constituents are required, and the large data matrix we will get out of it. So main characteristics of the receptor models are the users used to measure concentration at the receptor level, and the chemical mass balance principle is used, and the multilinear equations are used. Don't require complex metrological and chemical processes and low computational industries, because we are measuring the pollutant level at the receptor point. So we don't want any metrological data to know how it is getting disposed. We know how it came here, so we are understanding how much it is there. So there is no complex metrological data are required. So how the procedure is going? Preliminary evaluation, defining the methodological framework, criteria selection, what is the site, what is the species, what is the minimum number of sample. Then chemical analysis, then finally preliminary data quality check. So this six are the important procedures mapping for the RM, that is the receptor model. So the input data uncertainty calculation, selection of receptor model, finally factor analysis and test for model performance, reporting the results. You can see how the study area was preliminary evaluation of the study area was happening. First, we are collecting the data. This receptor model will work with the data collection again. So emission inventories, time series models. Again, we need everything. You can see here spatial distribution of the pollutant we need. What are the hotspot we need to know, and meteorological data. It is not the complex meteorological data. The basic meteorological data we need for the receptor model. Then the physical systems we need, what are the terrain, mountain regions, how many buildings, that is the land use, land cover patterns, everything we need. And then methodological framework is primary evaluation, objective formation, how much fund is there and time is available. Based on that, we can fix the receptor model, what type of model we are going to use. The model is PMF and CMD, like chemical mass balance model or PMF model. And then input data sources, required qualification, that is the testing of the results we have to do. The site selection is that represent a diverse range of sources. It should accumulate all the sources. Like Delhi is a big, good site that can be used to project the air pollution in the around. So you can take the solution site that could accommodate all the sources of air pollutant, and multiple site with the same or different characteristics are frequently used. Okay, so here you can see the site selection, so that should contribute to the traffic, urban background and rural, both should be there. It's not only, it's that's called representative site selection, so it should not be having any biased system. And the species selection, what are the type of pollutant we are going to take? Like in the Delhi case study, they have chosen five pollutants. So you can choose based on the result what you need, or your study of interest, you can fix. So the species selection, major ions like sulfur, nitrate and ammonium they will choose, and carbonation fraction like TOC, OC and EC they will take. And nitrates is related with the particles larger than those associated with the sulfates, and ultrafine particles, that is with the gasoline and diesel exhaust. So what are the source if you are identifying, then you can fix the pollutant according to that. If you are working on with the vehicular emission, then you can fix with the carbon monoxide and NOx levels. So the sample, how many samples, that is based on the variety of conditions, like how big the area is, how many seasons you are going to address, and the multivariate technique what you are using to find the results. Based on that, you can fix the number of samples. Okay. So the data will, the number of sample may vary from the time also required, 24-hour samples or 8-hour sample for ozone, 24-hour sample for particulate matter, and then the V ratio, that is the variable number ratio, and degree of freedom need to be considered to find how many number of sample. Okay. So here you can see, and the sampling system or the analysis. So like filters are required for particulate matter estimation, and like chemical analysis of PM is commonly preferred for filter based methods. The air will come and it will be attracted to the filter, and then the remaining air will go out through the exhaust. So it's a simple filter method to find the particulate matter level. Then the change in the weight of the filter will give you, that's a gravimetric analysis, that will give you the concentration of particulate matter in the air per how much cubic meter of air you have collected. So that will give you the basic PM level concentration. Then compatibility with the analytical procedures, no interaction with sample, low impurity levels and high efficiency are required for sample testing. So you can see the filter papers before and after sampling for the PM. And local source profile that is required, that is the mapping to need to do after finding the results. I mean, if you know the concentration of CO2, then we have to map with some sources, right? For that we need the local source profile, that is called the fingerprint. What are the sources available for the emission? That and all we need for the city or the local region. So the previous work in the similar domain, or that can be also calculated, taken for consideration. And the chemical analysis like organic carbon and elemental carbon, like inorganic carbon we can find from ICP-MS and the AAS, that is a graphite furnace AAS, and then the organic carbon we can find from HPLC. Okay, yeah. Then the statistics analysis, after getting the results, how to do the statistical analysis to eliminate the unwanted data. So if you get, I'm calculating the PM at different locations. One will be 100, one will be 90, one is 95, one is 10. Then we have to eliminate this data because it's not related to this. Because for average, if you take this 5, then your result will be 60. So I should not take this 10 as a reading. So that's the statistics you have to think about for calculating the average concentration levels. So some summary plots are required. Many commercial and free softwares are available for the statistical analysis. So first is the central and dispersion statistics that uses the box and whisker plots. So this is the whisker plot where they will say, or the box plot. So that will give you. So I'm rewriting the same in a vertical plot. If you see here. So this will be your x-axis and this will be your y-axis. Oh, sorry. This will be your y-axis, this will be your x-axis. And if you know the CO2 level and particulate matter level, so I can plot it in a, so it is 10, 20, 30, 40, 50, 100. So this is the box plot that will give you. So if I am saying like this is the box plot. So after getting concentration of CO2 from 100 locations, say for example, so this is the level. This is the minimum. This horizontal level shows you the minimum level of CO2 of this 100 values, and this will give you the maximum level of CO2 at 100 values. And this box gives you the lower and the higher quadratile. That is lower quadratile, upper quadratile, and this is the total inter quadratile, and the median value is here and the mean value will be here at the center. So you can find most of the values are between 20 to 60 and the maximum value is 100, minimum value is 10, but most of the values are between 20 to 60. So you can tell the median is around 650 and the mean value is 45. So that all the data you can get, all the statistical data you can get from this Bhaskara Discuss plot, and the maximum and minimum value also you can get. And you should not take 1000 as the maximum value for this boxer plot. That is a unwanted data that you have to delete. Okay. And then you can also represent in the terms of histogram or any possible plots you can go with, probability plots. And this is called a correlation matrix. So if you have the data at different average CO concentration and pollution exposure responses, these are all the data. So I can draw a trend line or a correlation matrix line. So that will give you a straight line which is the average of all these points. So it's connecting and giving you a line. So you are finding the R square. If the R square value is uh, I mean nearly equal to 1 or greater than 90% or 0.9, then your data is good to use. And if you have the same plot, I am redrawing again. My values are between here and here. My values, one is here, one is here, one is here, one is here. Then my line will be like this to connect all the 4 points. If you are connecting exactly, the line will be like this. But if I need a straight line, your line will be like this. And if you find the R square will be a zero point 0.4 or zero point 0.3. So it is not a proper curve. I mean, it's not a proper straight line. Some curvature is there. That's what the R square mentions. So the curve should not have any curvature. R square should be 1. Then it's a proper straight line. Okay, so that correlation matrix you can get from this, and then linear regression analysis you can do, and time trend analysis you can say this is for seasonal variation. If you are finding any pollutant at the different seasons, you can use the time trend graph from June to April, how it is varying. That's the time trend graph for seasonal analysis. And then outliners, that's what the unwanted data I'm talking about. Those are the error minimization technique. And spatial distribution, because if you know some part there may be more concentration. If you are going with any sodium ion in the air, So some seashore areas or coastal region, they may find more Na level. That is not the pollution. That is due to the salt level in the water. So that may also be emitted in the into the air. So that also you have to eliminate, and you have to consider the other sources for this consideration. Then it's a ratio scatter plotting. So this is a two receptor species. If you have by representing the concentration of two receptor species, one is a petroleum, for example, one is from petroleum exhaust, one is from wood burning. What is the concentration level? So that will give you a source contributor of different species. So that also you can get ratio scatter plot. And then the missing value from that is a zero and negative values will not have any meaning. So that all need to be removed. So you can, that is called the simple option to remove the row or row from a sample or a column from a sample. And the alternate approach to filling is the mixing value is the mean and median value. So some of the value you can take out and you can use the median and mean value instead of that. And if you check the concentration of some of the pollutant, that may be in the below deduction limit. If I am checking mercury level or arsenic level, that are all minute heavy metal present in the air. So that will give you sometimes below deduction limit, because my instrument may check only up to 0.001 microgram per meter cube, but it is less than that my instrument cannot measure. So that's called the below deduction limit or limit of deduction. So my instrument have a limit of deduction. If it is below that, that and all, that values and all, I have to eliminate. And maximum deduction level also, after that I should eliminate the limits, I mean values. So between lower deduction and the upper deduction limit, I have to use the values. Okay. And the signal to noise ratio, if you are seeing the FTIR plots or any plots, there may be, if you want a graph like this, you may not get the exact graph like this. So you will have a noise level due to the instrumentation operation or external factors. There may be a noise. That noise need to be eliminated, and you have to get a perfect curve like this. So that process is called a noise reduction techniques. So whenever your results are having a noise ratio of less than 0.2 or greater than 2, that need to be eliminated, and a suitable value is the sign, I mean the signal to the noise signal is your result to the noise ratio will be between 0.2 to 2. Okay, then mass closure and ion balance is preliminary data quality. These are all I'm talking about the data quality checks. So some missing values and below deduction levels if it is matching, and SBN ratio if it is matching, and the neutralization method you can use. If the positive and negative ions, if you neutralize, that should be zero. Then it is a proper check to measure to validate your process. And analysis of consistency in the time and the space. If I am detecting getting the value of 100 today, and tomorrow it is 150, and day after tomorrow it is 120, there is a consistency in my result. If it is going 1000 in a day, then it is an inconsistent data. That and all I have to take care. So that is all unusual patterns I can observe. Okay. Then analysis of consistency in times and space. You can see the same timeline graph, time trend graph. Yeah. So uncertainties also need to be incorporated in both these models, and you have to get the result. Then the selection of receptor models. As I mentioned, there are two models. One is chemical mass balance, and another one is positive matrix factorization models, CMB and PMF model. CMB uses is a least square model, which estimates the source contribution on the basis of chemical footprints and the concentration of the pollutant. But PMF model is based on uncertainty weighted factor analysis, which relies on the pollutant measurement. So the main strength in the CMB is does not require large data set. It's a theoretical equation can be solved for an individual pollutant. CMB does not require any additional identification. Yeah, here you can see. So it uses the multilinear regression and the principal component versus the total PM mass, that is particulate matter mass. This is another model, that is the APCA model, that is you can see here absolute principal component analysis model, that gives different source and its percentage allocation. So for model validation, you can use ratios, you can use residuals. So I am saying about what is ratio, that is a unique source traces are rare, that therefore the elemental and the molecular ratios have often been used as a trace similar sources. So trace similar sources are used to validate the model. After getting the results, how to validate? We can use the older historical data. If I am getting the PM levels for 2050, So it is getting higher. 2010 it is this much, 2020 it is this much. Then I'm extrapolating to 2050 and 60. Then I'm getting this value. How to validate this? So based on the historical data, I can use that to validate the future predictions. So some data I can use for prediction, some data I can use for validation. So that is called ratio, and then residuals. Residual range should be from +3 to -3. That is residue. The distribution of residue should be invested in order to verify how the model fit. That's called a model fit. And then time trend you can use as a validation. Wind direction analysis, the windrow maps. This is called windrows maps. So that will give you the direction, the intensity, the time at which the wind blows, number of times, that's a percentage distribution, everything you will get from this windrows diagram. So intensity, everything I can get. So that also you can use as a validation for your model. So it's a simple but reliable method is a plot source contribution in a polar scatter plot. This is polar scatter plot for wind directions. So in such a way, the wind direction determines the angle and the source contributions. Then the overall uncertainty can also be computed and it should be incorporated to the model. So how to report the result finally? It should be a model and the version need to be there. What are the input data you have given? What are the unquantifiable data? That also you need to report in the results. So if you see a receptor model example, we know the value of calcium and ferric in source. So you know the calcium concentration you have measured and the ferric concentration you have measured. And they are saying 0.9% of calcium is coming from soil dust and 0.2 are from steel plant. The same they have given for the ferric. They are asking pollution contribution of each of the sources in the ambient area. So I need to know how much source, how much from percentage from soil dust, how much percentage from the steel plant. That is the total they are asking. So for 50 is the concentration I know, 15 is the concentration of a ferric I know. So if it is, this is the fraction. So fraction int F and fraction into F soil, that is a two sources I'm talking. So that if you add, that will give you the total pollutant concentration. So if you find F steel and F soil, then you will get the concentration from the steel and the concentration from the soil emission. So if you plot a percentage for that, you know what is which is which higher contributor and which is lower contributor. One is 52, another one is 12. Okay, so this is the result from the source apportionment. So the receptor conclusion note I'm talking like a receptor model plays an important role for source apportionment. So they uses two models. One is PMF and another one is CMB. So receptor models are user friendly and easy to operate. So finally, we are going with the indoor air quality. So this is a new topic we are going into. So we as of now we have discussed about the air pollution. That is the ambient air pollution. That is the environmental surroundings. What is the air pollution we are getting? Now we are going to discuss about the indoor air quality. So there is a myth called only outdoors are having the air pollution only from the industries and from the vehicles, not in the inside the home. But there is a indoor air pollution. There is a chemical, biological, and physical contaminants on the indoor air. So the truth is, air inside the condition space have more polluted than the outdoor air. So that is the actual truth. So how this, what causes this indoor air pollution? Like air tightness of the building. So you are in a closed building or a closed environment. That again aggravates the concentration of the pollutant inside your room or a home. So poorly designed air conditioning system, if you see here, that will also contribute lots of indoor air pollutant. And the indoor source of air pollutions, like lots of sources we are going to see, and then outdoor source of air pollution, that is again contributing to your indoor air pollutants. So the pollutant sources I'm saying like outdoor air, chullas, the cooking with the firewood, that will also give you the emissions. Even LPG also will give you volatile carbon emission, tobacco, dust, whenever you're sweeping, and then mosquito repellent or any perfumes if you are using, that are all micro level liquid particles that will also give you irritation in your nose and all. This also considered as a pollutant. And wall and furniture paintings, agarbattis, and wood and paper burning inside the home, that will also contribute to the indoor air pollutant. So the air tightness of the building. So whenever the building is having have a hazardous impact on the air quality, so by reducing the ventilation rates. So if you have a proper ventilation, then it's directly proportional. I mean, sorry, indirectly proportional. If you have a proper ventilation, then your the indoor air quality will be good. So it's the positive air pressure. Positive air pressure moves the air out of the home, but negative air pressure brings the air into the into your home. So outside air rushes in to try and balance out the pressure difference. So that is again harmful to you. Then poorly designed heating and ventilation system. We can see lots of dust formation still in the air conditioning system, and molds, fungi, and other sickness causing microbes will may stick to this furnitures. So source of IAP. IAP is indoor air pollutant. In the typical households, there is from all our cabins we are having this air pollutants, from bathrooms to bedrooms and the kitchen. Everywhere we are having air pollutants causing agents. You can see in bathrooms if you see microbial pathogens. In bedrooms if you see mites from the bed sheets. And laundry room there may be a microbial pathogen. And kitchen there is a cooking emission again. Living room there may be animal hair, animal I mean dendrins that are having micron in level that may enter into our nose and it may cause health effects. And VOC from the paints, varnishes, furnitures that may also um, contributes to the air pollutants. And office building also you have printers that may emit some particulate matters that is a carcinogens. Again, copier if you see volatile organic matter particulates and the ozones, and what are the laptops that may emit VOCs, bioaerosols from every plant will also emit bioaerosols, and painted walls may emit, carpet may emit particulate matters, and pesticides, everything, even vehicular emission may contribute to smog formation as we discussed. And the source of contaminants like outside building equipments, chemical release from the buildings, indoor human activities, building components, and others. You can see all other type of pollutants here. So I'm just skipping this because this is and all like what are the sources that may give you indoor air pollutants. So here you can see human activities like smoking, cooking, body odor, and cosmetics are also considered as indoor air pollutants. So building components, if you see unsanitary conditions, if you are keeping any buildings, or accidentally also it may happen like spillage of liquids, microbial growth, or if you have any painting activity during the time that is all accidental or purposeful indoor air pollutant comes. Yeah. So why we need to study indoor air quality? Because EPA result shows people spend over 90% of their time indoor. Okay, so there is a 2 to 5 times higher pollutants are found in indoor compared to outside. So that is a like if you see the statistics, you can like indoor air pollutants are more harmful than the outdoor air pollutant. And who results shows that more than 30% of all commercial buildings have significant IAQ problems. If you see, go into all the commercial areas like mall or any residential, I mean restaurants, you can find more than 30% of all these buildings are having indoor air quality problems. So historical perspective, we have discussed in the first slide itself. In the mummified humans, if you taken from the Egypt and all, they found the lungs are blackened due to the coal particle that is present in their lungs. So that may be due to the burning of coal or any firewood during the ancient times. And mining activity also, they have seen lots of death was happening due to poor industrial activity, or what can we say, like ambient, poor ambient they have maintained for the occupation. Yeah. Then asbestos is considered as a major indoor air pollutant because it may emit smaller fibers that will affect the human health. It's a it was identified as a carcinogen, and high concentration of radon was also identified in nowadays in indoors, and that may contribute to lung cancer. So they have banned the asbestos nowadays in construction in India, and 3.5 million deaths and 4.5 global daily adjusted life, that is called daily adjusted life year. So that is also due to indoor air pollution from solid fuels, and they account 16% of particulate matter pollution. And what are the factors affecting IAQ? Your temperature, humidity, again, age of the indoor structures, and different what are the types of sources and concentration also contributes to the indoor air quality. And what are the health impacts? It will reduce your the oxygen level in the space, and it will increase the carbon dioxide level, increase the temperature, increase the humidity, increase the bioaerosol, and other everything causes health effects. Like short-term effects like headache, noise, nose, throat, and eye inflammation, coughing, and all skin irritation. But long-term effect like carcinogens, most are carcinogens. So respiratory disease like asthma and cancer, and headache and anxiety that will affect the nervous system. So these are the different health effects due to different pollutants from indoor air pollutants. Like radon is one of the, and respirable suspended particulate matter, respirable and suspended particulate matter. So that will also get into our lungs and it will cause the health impacts. And sick building syndrome is the one word you can think about, SBS. So sick building syndrome is used to describe the situation in which the building occupants experience acute health and comfort related effects. So whenever if you see some people when they are going into a building, they will feel sick or they will feel headache or they will start cough. So sneezing. That may be due to the non-maintenance of the building, or there may be some indoor air pollutant that is called a sick building syndrome, but no specific illness or cause by, can be identified. Okay. So what are the solutions for sick building syndrome? Pollutant source removal, increasing ventilation rate, air cleaning, and education and communication to keep the building clean. So ventilation we can do by natural, mechanical, and hybrid ventilations. Yeah. So you know about the ventilation rate, airflow direction, and the air distribution. These are the basic three steps need to be considered for designing any building. So as engineers, we know how to design a building with the ventilation. And natural ventilation you have to keep through windows, and limitation is like it's not uniform always, because whenever you are giving any mechanical ventilation it will be uniform, but natural ventilation may come sometimes and may not come. But if there is an outdoor air pollutant, that will also come into the indoor, so like pollens and other pollutant may also enter indoor. But mechanical ventilation, if you go, that will give you a proper, I mean not proper, continuous supply of ventilation, and that's principle is pulling fresh air from the outside, exhaust stale air, and controls the temperature and humidity. Hybrid is both indoor and, I mean, natural and mechanical modes. So it uses mechanical ventilation when the natural ventilation is too low. So how to assess the performance of the ventilation system? By sufficient, does it provide the sufficient ventilation for a building? You have to assess the ventilation. So here in architecture department, it's also I had seen lots of the thesis. They have worked on ventilation of the building. They have worked on indoor cooking environment air pollutants. So I have seen lots of thesis on that also. So you can refer most of the indoor air pollutant due to ventilation problems. Yeah, you can see the health effects. So on a conclusion note, indoor air quality assessment and management need more attention, and it will also contribute to the health risk. So as a final note, we are seeing what is the specific source and types. So that we already discussed. Anyway, we are going to see again. So inadequate ventilation, high temperature and humidity, indoor air pollutant are the primary causes of AIQ. So the sources are fuel burning, use of tobacco, building materials, household products, heating and cooling systems. Outdoor air pollution also contributes to the indoor air pollutant, pest control activities. Yeah, you can see. So the indoor air pollutant we already discussed. Combustion products, like cooking and all we are using, and then carbon monoxide may be released as a colorless, and it's a combustion product, incomplete combustion product. So that will release other colorless toxic gases, lack of oxygen, and due to low mixing. And nitrous oxide, if you see, so that is the two prevalent oxides of nitrogen, that is N2O, that is nitrogen oxide. Sorry, NO2 is a nitrogen oxide and nitric oxide is NO. So they are highly reactive oxidant and corrosive. So that is the guidelines for N2O, that is 0.05 ppm as the average of 24 average hour limit, and NO2 in outdoor air. And the sources are, so CO sources are incomplete combustion, but for NOx there is a unvented combustion appliances, welding, tobacco smoke, kerosene heaters, and all. So PM, particulate matter is emitted in the indoor due to complex mixture of solid particles that may be having a 10 micrometers diameter, that is PM10, and we are having even micro level fraction, that is PM 0.1 also there. So that is called that size is based on the aerodynamic diameter, not the actual diameter of the particle. So aerodynamic diameter is the one which have the diameter of a particle which can float in the air. So 0.1 diameter of the particle when it floats in the air, that is called the aerodynamic particle, aerodynamic diameter. Okay. Yeah. So if you talk about coarse particle, that is PM10, that is inhalable. Even PM10 itself inhalable into the lungs, and PM2.5 that is a fine particulate matter resulting of burning of fuels and chemical reaction. It may form ultra fine particles of PM 0.1. So that originates from similar source of PM10 like burning. Ultrafine particles pose a worse threat than the PM 2.5, can infiltrate into our body even greater extent. If PM10 itself go into the lungs, PM 2.5 can go into the arteries. Then think about PM 0.1. Then second hand smoke. Somebody is smoking and we are getting the pollution. So that is other causes of indoor air pollutant. And the second hand smoke was classified by EPA as a group A carcinogen. So that's a major problem for others. And you can see like nearly 34,000 premature deaths are happening from heart disease due to second-hand smoke. And you can see lots of statistics regarding that. And building materials, if you see asbestos, formaldehyde, lead, and VOCs are major pollutants. So asbestos from rocks and the soils, they are burned now due to their fine particles emission. And formaldehyde is a chemical used in the manufacturing industries. So their concentration may vary according to the age of the building, temperature, and the air exchange rates. And formaldehyde is a resin used in the manufacturing of composite wood. So every furniture you can see this. And also it will be available in fertilizers and pesticides. Lead initially they we found in petrol also. Nowadays leaded petrols are banned, and small amount of earth crust is found in, and toxic to humans and animals and cause health effects. So they are removed from dry scraping, sanding, and open flame burning. Sorry, emitted from. And lead sources are remolding, dry scraping, and demolitions. Volatile organic carbons are emitted from any fuels that may emit that may volatilization is what that is converted from soil to vapor or liquid to directly into vapor. So that process is called volatilization. So whenever there is a conversion from solid or liquid into gas, that is called volatilization. So whatever the compound which gets volatilized and having a small that will always have a benzene ring. Volatile compounds always have a benzene ring. Okay, so this type of that may have a good smell, or any smell will be there whenever there is a benzene ring. So volatile organic compounds are emitted from certain solids and liquids and constantly higher in indoor, up to 10 times higher than outdoors. So VOCs are higher 10 times than outdoors. That is a important number you have to note down. So what are the types of VOCs? Acetone, acetic acid, butanol. Butanol, if you see candles and barbecues, if we are going nowadays, and the gas stoves are emitting butanols. And carbon disulfates are emitted from chlorinated tape waters because carbon disulfate, CS2, that are emitted from chlorinated tape water. So you can see everywhere we are getting pollutants from the buildings. So that is the indoor air pollutant. Then ethanol, methylene chloride, these are all pollutants, indoor air pollutants. So you can see where it's coming out from: paints, woods, aerosol sprays, cleanser, pesticides also it's coming from the VOCs. And then the biological pollutants like bacteria, molds, pollens, virus, these are all biological indoor air pollutants. So that may be from beds, carpets. If you are not washing the carpets for a long time, you will find this type of bacterial infection. Also from animal allergens, the dander from the cats, dogs, and birds may affect the lung. Then the molds due to and then pesticides what we are giving to the plants. So in a study, 75% of the US households are using at least one pesticide for their plant indoors, and 80% of the most people's exposure to pesticides are from indoors only, not from outdoor agricultural pesticides. So the source of pesticides to kill household pests they are using, and using on the lawns and gardens they are using, that will also contribute to the indoor air quality. And the radon is a gas released from soil and rock. So that's a source for lung cancer, and highest level occur in basements and on the ground floor. And also you had seen, think about, you can read some case study on it's a landfill called in Mumbai, there is a landfill. They have capped the landfill to reduce the leachate concentration. Capping in the sense they have covered it with the liner system, so that will not rainwater will not enter into the landfill. Also, the methane gas that is produced will not escape into the atmosphere. So they thought the pollution was prevented, but actually there is no capping at the bottom or no liner at the bottom. Actual scientific landfill should have a proper liner system, and the waste will be there, and then we need a covering system. Then only there will not be any water intake, and gas outflow will be there. So then it will be prevented. Landfill, it's a place to dump the old wastes. So they thought the covering system will prevent all the pollution, but there is no ceiling at the bottom. So the methane gas travels through the trap, and it is traveling through the cracks in the soil, and it was emitted through the nearby apartment. And whenever CH4 reacts with sulfide, it will form a the copper and sulfide, it will easily attack, the methane gas will easily attack. So most of the electrical lines in the apartments are at the basements. So all the copper wire and the sulfide particles in the wires get affected by this methane, and they got a short circuit every time. Then they found out the reason is due to the methane emission from the industry, I mean the landfill, the closed dump site. So like this radon gas also can enter from the basement and from the ground floor, and it will enter into your home. That is the indoor air pollutant. So you can see how it is emitting from the soil. So conclusion is the indoor air pollutants also releases gas and particles, and it is more harmful than the outdoor air pollutant. Also, the level will also more compared to the outdoor air pollutants. So understanding and controlling this common pollutant indoors can help reduce your risk of indoor health hazards. Okay. So this is all about today. So we have seen a case study for emission inventory, and we have seen source apportionment, how to do with two models that we had seen. And in the last session, I mean lectures, we have discussed about the indoor air quality and the pollutant and how to control it. I mean how to control, we are going to see along with the outdoor air pollutant, but that sick building syndrome we have seen the solution. Yeah. So if you have any doubt, please unmute and you can ask, or we will move on to the problem solving session. Yeah. Okay. Then we will move on to the. You can also put it in the chat box if you have any doubt. I'll look into it. Yeah. Then I will move on to the problem solving session. Yeah, we will go. I will read the question. You can also put the answer in the chat box, or you can unmute and you can say the answer. No issue. Yeah. The first question is, what is the primary advantage of the bottom up or source based method in air quality management? So in air quality management, for a source apportionment, we have two methods. One is bottom up or source based method. The other one is top down or receptor based method. So they are asking about the advantage of bottom up method. Options are identifying a atmospheric layer, locating pollution source through emission inventories, analyzing noise pollution, determining wind pattern. So what's the pollution? Sorry, what's the advantage? So the source based method will first go to the source and it will get the pollution level. So it will locating the pollution source through emission inventories. That's the primary advantage of bottom up approach. That's what we had seen, right? Yeah. So this is the advantage of bottom up or source based approach. They locate pollution through development of emission inventories, and they identify the potential source easily through the primary emissions. So it will not go to the receptor. It will directly point out the sources. So understanding the chemical process, also it will calculate the secondary pollutant sources. Like the potential, it will also document the potential for secondary aerosol formation and provides the spatial coverage. And the disadvantages is what it requires a laboratory requirement, and we need expert staff to manage with the map and analysis. So that's why we move on to the top down approach. Top down is from the receptor based. Yeah. Here there is a second question is, what is the fundamental principle underlining receptor modeling in air quality assessment? What is the fundamental principle underlining receptor modeling in air quality assessment? So there are two principles for receptor model. Receptor model is what? Top-down approach. So they uses the mass conversion. That is a chemical mass balance, CMB. Mass conversion as a basic principle for, because we know, I will take the pen. In bottom-up approach, what they will do, they will go to the source, they will identify the source, and they will find the pollution level at different locations by Gaussian plume or Lagrangian model. But in the top-down approach, this is a bottom-up approach or source-based approach. But the top-down or receptor-based, they will first go to the receptor. What is the pollutant concentration? They will measure with the different equipments, and they will check for the source. So if I find 100, 10, 20 here and 30 here, then I will add up everything. That is the mass balance. So if I know the mass balance, then add up to give you here. So if 100 is emitted here, then surely 100 will be distributed somewhere. It's a mass conservation. That's the basic principle. So you can see here, top-down approaches begins by sampling of air, and the basic principle is mass conversion. Okay, that's the chemical mass balance, CMB. Okay. Then the third question, how is wind direction analysis typically represented in the model performance validation? So model performance validation was done for the different things. One is for wind direction. We have used Windrose diagram, right? That what's the plot we have used for the Windrose diagram? It's a this is the plot we have used, right, for the Windrose diagram. So it will give you the direction of wind, it will give you the intensity of the wind, it will also give you the percentage of time the wind was blown in that direction. So that there you can use the polar scatter plot you can see here. So the wind direction analysis was done for the polar scatter plot. A simple but reliable method is to plot the source contribution in a polar scatter plot for the wind direction analysis. So for different pollutants, we can use different plots, scatter plots, trendline plots, everything we had seen here. So if you know the answer, you can also put it in the chat box. Yeah. The fourth question is, what does the presence of large-scale residuals or a non-normal curve indicate in model validation? What does the presence of large-scale residuals or a non-normal curve indicate in the model validation? Residuals and ratios are used to again error minimization or validation. So if there is a large scale residues or non-normal curve, then it is a good fit or poor fit. It's a poor fit for the model validation. You can see here. So the residuals are it should be in the range of +3 to -3. They are saying large scale residuals. So if you see here, if a species has many large scale residues are displayed as a non-normal curve. If it's a normal curve means how it will be, more values should be at the middle and lesser value should be at the end. Then the curve will be like this. That's a normal curve, normal distribution curve. If it is a non-normal, somewhere it is higher, somewhere it is lower, again somewhere it's higher, then non-normal, and the largest residues are there. Residues are the difference. Then it is poor fit. Yeah. So fifth question is, what is the purpose of using elemental or molecular ratio in model performance validation? Elemental or molecular ratio. Again, it is the validation, model performance validation to determine wind direction, to analyze time trends, to trace similar sources, to measure solar radiation. So to determine wind direction, we are using polar scatter plot. Time trends, we are using again a normal line chart. Solar radiation or to trace the similar source. They are asking about the elemental or molecular ratios. What is actually that? You can see here ratios. That is a unique source tracer or rare. Therefore, elemental or molecular ratios have often been used to trace similar sources. So this ratio, that is the elemental or molecular ratios, are used to find what are the similar sources of the pollutant. In PMF factor, if you see, the elemental ratio for NaCl ratio was compared with the seawater comparison. So that is useful to trace the similar sources. That's what the elemental and molecular ratios are used to trace the similar sources. Yeah. So the sixth question, which of the following is not a basic element of building ventilation? Which of the following is not a basic element of building ventilation? So for the building ventilation to be considered, ventilation rate, airflow direction, air distribution or airflow pattern, air efficiency, air cleaning efficiency will not be there. So the basic element of building ventilation should consider ventilation rate, airflow direction, air distribution or airflow pattern, not the air cleaning efficiency. Yeah. So ventilation is just a flow, right? That's not considering the cleaning. So that's the building ventilation, three basic element: ventilation rate, airflow direction, air distribution or airflow pattern. Yeah. Moving to the seventh question. Which of the following is a common solution to sick building syndrome? What is sick building syndrome? If it's a building, whenever a person enter, they will feel a health hazard, acute syndrome, acute reaction. Then it is a sick building syndrome. So how to prevent the sick building syndrome, or what is the solution? So chemical spray, reducing ventilation rate, air cleaning, limiting education and communication. So we need to have a higher ventilation rate. We should not spray any chemicals. And education and communication should be required because we need to know what are the things which will cause most of the indoor air pollutant, and we need to also properly clean. So air cleaning is the best method for solution for sick building syndrome. So if you see here, solution for sick building syndrome SBS is increasing ventilation rate, pollutant source removal, air cleaning. So the spray may be a source, so that also need to be removed. Education and communication. This is the first solution to sick building syndrome. Okay. So eighth question: what are concentrations of VOCs typically higher? VOC concentration: indoor, outdoor, in ventilated areas, in rural environment. VOCs are higher in indoor air compared to the outdoor air. How much times? So they have given, right? It's 10 times higher than the outdoor air. So you can see the number, how big it is. The volatile organic carbon I'm saying. So indoor air VOC is higher compared to the outdoors. Yeah. So ninth question is, which activity is likely to increase the presence of butanol, a common VOC? So we have seen different VOCs from the indoor air pollutant. One is butanol. So where it is coming from? Cooking with proper ventilation, burning candles and barbecues indoor, using water-based polish, drinking bottled water. So VOCs are likely to increase the presence from burning candles and barbecues. Yeah, so the answer is B. So you can see here, butanols are coming from candles and barbecue and gas stoves. That is one of the VOC, common VOC. Okay. So the 10th question is again based on the same. Where is carbon disulfide, a VOC commonly found? Beeswax candles, in chlorinated tap water, in gas stoves, in glass cleaners. So we had seen this answer, right? In a chlorinated tap water only, carbon disulfide will be coming. So you can see the sources of different VOCs also. You can just read once. So candles and barbecue will contribute to the butanol, also the gas stove. And chlorinated tap water is main source for the carbon disulfide. Yeah. So thank you for joining this session. We are in the sixth week now, and the next session is Tuesday. Next Tuesday, 6 to 8 p.m. You will get the message, sorry, mail from NPTEL team. You can also see the recordings of this video in the Swayam portal. I will also show you how to see the portal. Let's see here. So below the sixth week, you can see. I mean, below all the week's videos, you can see download video option to download the videos, and the weekly feedback. You can also give the feedback for professor, and transcript you can download. That is the English transcript, and the book. There is a book. You can also download that. And the problem solving session is my videos, and you can also see my recordings here. That will take you to the Google Sheet. There you can find my 6 weeks videos here, and I have also uploaded all the presentations and some problem solving PPTs in this Google Drive folder. You can also go through this, okay? And after that, you can also give survey you will also get mail regarding the survey for a problem solving section. You can also give the feedback. You can also contact me through this mail ID. Thank you so much for joining. If you have any doubt, you can unmute and you can ask. I will be in the meet for next 5 minutes, or you can leave the meet. You can also put it in the chat box if you want. And if you want to write any question, you can use the Q&A session. I will periodically work with the Q&A portal here, and I will answer the questions. If you have any doubt in between the problem solving session, you can ask that. I will also answer to that. Okay. Thank you so much for joining. You can leave the meet now. Thank you. I hope you have registered for the exams and prepare well for the exam also. The exam date also they have mentioned. Thank you so much for joining. I will close the meet if you don't have any doubt. Thank you. Thank you so much. I'll close the meet. Thank you so much.